Hello everyone and welcome back. I am Mr. Covalent and today we are going to go over naming molecules or covalent compounds. So we are making our transition away from the ionic substances and now we're going to be talking about the molecular substances and how to name them. So you're not going to name these like the ions. So when it comes to the ions, and charges and things like that. Remember, we're using Roman numerals to identify the charge on the ion if there was a variable charge. We're not using Roman numerals, so do not use Roman numerals when you have molecular substances. So the first thing you always want to do when you're naming a substance is classify the substance. Is it ionic or is it covalent molecular? And the way you do that is you just see if there's a metal, right? So if you have a metal and a non-metal, that's going to be ionic. And so now you know you're going to name it in the ionic way. And then you got to figure out, is the metal a variable charge metal or is it only a single charge metal? What's the case, right? If there is no metal and all you have are non-metals and there's no charge, right? So here we have nitrogen, oxygen, those are non-metals, and there's no charge. So that means it's not an ion, okay? So this is a molecule. This is a covalent compound. So I need to name this in a different way. And the way we're going to name this is really simple. All we're going to do is we're going to use our Greek prefixes in order to identify the number of atoms of each of the elements. That's it. So in an ionic compound, we don't need to identify the number of atoms in the compound because we already know that based upon the charge, the balance of charge, and the formula for polyatomic ions. So we don't need to figure that out. We can figure that out from the name of the ions. But here, the name has to indicate the number of atoms in the compound. So we're going to use the Greek prefixes to identify the number of each atom of each element in the compound. And then that's it. So I have written on the board here the way the name is going to go. Your first element, your second element. These are binary elements. We're not going to talk about how to name anything that has 3 different elements or 4 different elements. This only applies to compounds with 2 different elements in the compound. So your first element in the compound, you're going to have a prefix that identifies the number of that element and then the name of that element. And then you add to that the second part of the name for the second element. So you're going to need the prefix that comes first. That's going to identify the number of that element or the number of atoms of that element, followed by the name of that element. But then again, just like the ionic compounds, that last part, if it's a binary ionic compound, you got to drop the ending and add IDE. So this part of the name is going to be very similar to the naming of the binary ionic compounds. Okay, so let's go over, I have several examples. Let's see how this is done. So one of the things I want to mention first is if I only have one of the first element, if the first element is only 1, then I don't use a Greek prefix for that. So I just give the name. So this, I should write unless you only have 1. If you only have 1, then there's no prefix. And this only applies to the first element, not to the second element. The second element, you will always have a prefix, whether you have 1 or not. Okay, so here I see that I have only 1 nitrogen. So I'm just going to name this nitrogen. So the name of the first element, nitrogen. I'm not going to have a prefix because it's only one. So this is the first part of my name, nitrogen. Okay. Now the second part is I need the prefix and the second name. So this is oxygen. I have 2 oxygens, so I'm going to use the prefix for 2, which is di. And then the second element, I'm going to name it just like I would an ionic, an ion, right? So in our binary ionic compound, like for example, if I had aluminum oxide, right? So I named the aluminum ion, the oxide ion, so I put them together, aluminum oxide. So I'm going to treat this, when it comes to naming, I'm going to name it like I would an ion. So here it's an oxygen, but this time, instead of having no prefix, I'm going to have a prefix there to indicate the number of oxygens I have. So I'm going to name this dioxide. So that's the name of this molecular compound here. So nitrogen dioxide. What about this one? So now I have 2 nitrogens, so I have to have a prefix. So I'm going to use di. So it's going to be di and then the name of the element. So with the name of the first element, I don't have to drop anything. It's just the name of the element. So di nitrogen, okay? And now I only have 1 oxygen, so I'm going to name that monoxide. So mono plus oxide. Since mono and oxide both have an O, I'm going to drop 1 O, and I'm going to keep writing oxide, so monoxide. That's it. So let's keep going. Okay, what about Ni3? Again, N for nitrogen, I only have 1, so no prefix, just the name nitrogen. Nitrogen. I have iodine. I have 3 of them, so I need to use the prefix for 3, which is tri. So again, iodine, in an ionic compound, I would name this as an ion iodide, so that's what I'm going to use. So I'm going to drop the ending at IDE. So this would be tri iodide. And you'll notice that I keep both I's. So in this case, triiodide sounds good. It rolls off the tongue. It's not hard to pronounce. So I keep both I's, triiodide. All right, next one. I have PCl5. Again, I only have 1 phosphorus, so I just write phosphorus, no prefix. So phosphorus. And here I have chlorine, 5 of them, so I need to use the prefix 5, penta. And again, if this was an ionic substance, I would say chloride, so I'm going to use chloride because I have to drop the ending at ID like I did before. So then this is going to be penta chloride. That's it. That's the name. Let's go to the next one. This time I have 4 phosphorus atoms. So I need to use 4, the prefix for 4, which is tetra. So this is going to be tetra phosphorus. Tetra phosphorus. And then here I have 10 sulfur atoms. So I need to use the Greek prefix for 10, deca. So I have decasulfide. Decasulfide. So decasulfide. Okay, now for the last one. So here I have nitrogen and oxygen. I have 2 nitrogen. So again, di for 2, followed by nitrogen. So I have dinitrogen. And then here I have 5 oxygens. So I'm going to use penta for 5. But again, because I have oxygen, oxygen begins with a vowel. So having those 2 vowels together doesn't really help. So it'd be pentaoxide. So we drop the A and we just say pentoxide. So drop the A and it's going to be pentoxide. So not pentaoxide, pentoxide. So dinitrogen pentoxide is the name of this substance here. And that's how you name molecular substances. Again, no Roman numerals because there's no charges. Remember, the Roman numerals only go with ionic substances and they go with the metals that have variable charges. So we're not dealing with ionic substances here, so you don't want to use Roman numerals. We're only using the Greek prefixes to identify the number of each of the ions. And the only time we don't use a Greek prefix is when we only have one of the first element. I hope this is helpful. I hope you enjoyed the video. If you like the video, like the video. If you like the video, share the video. Please subscribe to the channel and make a comment in the comment section. Tell me what you think. Ask me any questions. What do you want me to go over next? And make sure that you hit the notification bell over there. And that way you can get notified for any new videos. Thank you for joining me, and I'll see you next time.